All right, so we're going to wrap up 7.2, talking about radians here today. So, understanding radian measure of a circle, unit circle, it says, what is the radian measure of an angle? So, radian measure is defined as radian measure of a central angle is equal to the length of the arc on the unit circle subtended by that angle. So, basically, the idea is however many degrees this angle is, the equivalent radian measure is however whatever this distance is, given that it's on a unit circle where the radius is 1. All right. So 1 radian goes roughly this far. And the reason for that is we know the full distance is 2 pi. So 2 pi is about 6.28. So 1 gets you to here, 2 would get you to like here, 3 would get you almost to this because pi is like 3.14. And so that's the idea is what 1 radian is roughly that distance or that portion of the circle. Okay. And so that's what it is. That's what we have to do. That's how we figured out. Things to understand, like definitely numbers you want to remember is 180 degrees. So half the rotation is pi. That's a really key one to remember. If you do half that, it's pi over 2 for obvious reasons. If you go to here, which would be 270, 3/4 of a circle is 3/2 pi because it's a pi and another half. And then the full rotation, 2 pi is 360. So there's definitely some key values to kind of remember there. This is 90 degrees, this is 180, this is 270, and this is 0 or 360 if you've gone all the way around. And so 360 would correspond with 2 pi. And so degree to radian, that's the conversion. That's how they're related to each other. Okay, so this says, how can you use radian measure to sketch an angle? So eventually we'll learn how to do this exactly, but right now just make sure we understand the concept. So if they say something is 4 pi over 3, so in other words, 4/3 pi, that's a little more than pi, right? So 4/3 pi is going to go to pi, and then another third of the circle. So if we're thinking about what this is going to look like, okay, here's our unit circle. That'll get us to pi, and then 2 pi would be all the way to here. We want to go just a third of pi, so it's going to be like roughly here. And so this right there would be a 4/3 pi radian, okay? Another one here, -5/6 pi. Okay, so same kind of concept. Negative means we're going this direction. If we went all the way to pi, that'd be here. This is 5/6 of a pi. So, think of it as 5/6. If you divided this into 6 equal chunks, it would be roughly here, would be 5/6 of a pi. So -5/6 of pi. All right, so those are, again, just sketches, just conceptually understanding what we're talking about when we're talking about radians. All right, so here's the conversion part. This is what's really crucial or key to understand. So it says, how do you convert between degrees and radians? 1 full rotation, 360, is the same as 2 pi. So this is exactly what we said on the previous page. These are these relationships that you want to make sure you understand. And the real key one is the direct 1 pi is equal to 180. That's the one we use for conversions. Technically, you could use any of these for conversions, but that's generally just the easiest one to work with. So in this question here, when they're asking how do you convert them, so how do you convert whatever your angle measure is from radians to degrees or degrees to radians? You're either going to multiply by pi over 180, or you're going to multiply by 180 over pi, depending on which thing you need to cancel. And what I mean by that is, if we have something with a pi in it, we want to get rid of that pi. So we're going to take the pi over 7, and we're going to multiply it by the one with pi in the denominator, because that is going to give us a conversion where now the pi's will cancel each other out. And 180 over 7 is going to be some amount of degrees. So 180 over 7 is 25.7 degrees. Okay? If you really wanted to check this, which, you shouldn't need to, but just to sort of prove to you that this works. So I'm in degree mode right now. So if I do sine of 25.7 in degree mode, I got this. If I switch over to radian mode and I do sine of pi over 7, I should get the same value. And I do. Basically, obviously, they're not exactly the same because I rounded my 25.7. It was actually like that. If I put that actual value in, then they'd be spot on. But again, that's sort of a way you could check this. But really, this conversion isn't super complicated as to where we would need to do this. So again, I'll be aware of radian versus degree in a calculator. All right, so that'd be our degree. If you're given a degree, though, you want to convert it to radians. So you need a pi on top. So we're going to multiply by pi over 180. And really all I do here is I take my 75 over 180 and I just reduce that fraction. So 75 over 180. And if you're using a calculator like this, you can go math fraction and get it in simplified form real quick. So 5 pi over 12. Or you can just, old-fashioned way, look at this and be like, oh, these are both divisible by 15. I can divide them both by 15 and boom, get to here. So both ways work. It's up to you. But yeah, that would be our then radian measure. Okay, a couple more down here. If you want to go ahead and try them, go ahead and pause it and do so. So I have a degree multiplied by pi over 180. Again, I'm going to want to reduce that fraction. So I'm going to take my fraction and reduce it. So 28 over 45. So 28 pi over 45. There's my radian. If I'm given a radian measure, multiply it by 180 over pi. Again, that way the pi's will cancel. And 180 over 6 is 30 degrees. I don't know why I'm typing that one in. And there we go. Not too crazy, but again, the pi over 180 is a really simple, easy way to convert these. You could do it with 360 and 2 pi if you wanted to. You could use any of these ratios if you wanted, but pi and 180 seem to be generally just the simplest to work with. Cool. All right, so let's take a look at 6. So it says, NASA's tracking a satellite traveling in a circular orbit above Earth. It can only be tracked while it orbits through a pi over 6 angle. Okay, so it's got to be at a specific angle to be tracked. The radius of the Earth is 6,400 kilometers. What is the distance the satellite travels while it's being tracked? So radius of the Earth plus it's also 320 kilometers above the Earth's surface. So this is like the total distance it is away from the center of the Earth, which is like the circle. So here it does have a little better, like a mathematical sketch of this. So you've got your 6,400 kilometers and your 320 kilometers. So that makes the full radius there. If we add those together, that's 6,720. That's like our total radius. Okay, so that's the whole distance across. They say it's getting tracked from pi over 6, and they want to know, what is the length of the arc? So the question is, what is this distance right here? All right, so there's a few ways to think about this. I'm going to kind of explain it a couple different ones. So this is the radian measure if we were dealing with a unit circle. So if the radius was 1, so if this radius was 1, our arc measure would be pi over 6. Our radius isn't 1, though. Our radius is 6,720. So all we need to do is if we take our radius and multiply it by the number of radians that this covers, that's going to give us this length. It's simply going to be a multiple of 1. So all I have to do here is 6,720 times pi over 6. And we probably want to give this, I don't know if it says a specific thing, just as what distance. So we probably want to just get this as a decimal because we're going to be talking in kilometers here. So if I take my 6,720 and I multiply it by pi over 6, I get 3,518.6 kilometers. And this actually makes sense because if you think about with these numbers, we could actually figure some stuff out, right? We could figure out the full circumference because we know the radius. If the radius is this, right, we could do 2 times our radius times pi. The full circumference, if this satellite traveled all the way around the Earth, is about 42,000. Pi over 6 is a sixth, or actually overall a 12th of the whole circle. So if you notice, that's our same exact number that we just had. It's all related. There's a lot of ways you can figure this out or logically come up with what this distance should be. Okay. So either way, this is my distance traveled on the arc. The little follow-up question here says, if a satellite could be tracked for 5,000 kilometers, what angle in radians would allow it to pass through? So they're basically saying if this was 5,000, so how would we work backwards? So we have the same, the Earth isn't changing. This is like our unknown, and it equals 5,000. So we just think about this exactly like what we just did here. All we have to do is divide the 6720 from there. So 5,000 divided by 6720. Looks good. So what angle in radians? So so here we get x is 0.744. But radians are usually given in terms of pi. So we're going to want to actually adjust this to account for that. And what I really mean by that is so this decimal, this 0.7444, if we divide it by pi, I divided by pi to try to write it as a fraction. But you can't because this is going to be an irrational number. So even though when we're doing these and we have specific values, they usually have a pi in them. Radians don't have to have a pi in them. If we can write them that way, we always should. But when you've got a decimal like this, it's a rounded value, and you can't really reduce it or divide it by pi. You're going to want to just leave it as a decimal value, which is perfectly fine. 0.744 radians is just a small portion of it. Like for comparison, pi over 6 is 0.52 radians. So obviously this is a little bit more because it's going a little bit more of a distance. So you can kind of compare them that way. You could probably find out an approximation of about what this was if you were going to, try to just sort of go through and roughly guess what it would be. But again, leaving it as a decimal, perfectly fine here. And I think that's all, right? Yep. All right. So try out some of these degree to radian problems and hopefully it goes pretty well.